Hi everyone, I am Dr. Bala, Assistant Professor, Department of Mechanical Engineering, Kamaraj College of Engineering Technology. Today class we are going to see about the problems on cantilever beam. So cantilever beam, in the sense it is a beam fixed at the one end and free at the other end. So this is the cantilever beam. So cantilever beam is fixed at one end and then free at the other end. So problem, so first I dictate the problem. A cantilever 1 meter long is loaded with a uniformly distributed load of 2 kilonewton meter run over the length of 2.5 meter from the free end. It also carries a point load of 3 kilonewton at a distance of 0.25 meter from the free end. So draw the shear force and bending moment diagram of the cantilever. So this is your problem, and this is the diagram of given cantilever beam. The beam is fixed at the one end and then free at the other end. The beam is carrying the two types of load. One is the point load, the other load is the UDL load. Okay, so first shear force. Before solve the shear force, we should know about the sign conventions of shear force. For a cantilever beam, we consider beam as the right hand side. We consider beam as the right hand side. For shear force, right hand side upward negative and right hand side downward positive. Right hand side upward negative and right hand side downward positive. Here two types of load is acting. One is the point load and another load is the UDL. UDL means uniformly distributed load. So consider beam section at the right side. Right side means these two loads acting downward side. So it is considered as the positive load. So it is considered as the positive load. So this is the first step. You should know which side we are going to consider the beam section. In cantilever beam we are consider the right hand side section. Then now we are going to solve the shear force. So shear force from right hand side to left hand side, we are going to solve the shear force. First one, SF at B. So SF at B, here there is no load is there. Here there is no load is there. So SF at B 0 kilonewton. Then SF at C, in C there is a point load as well as UDL load is also acting right side to the C point. So SF at C without point load. SF at C without point load. So here the UDL load is acting 2 kilonewton per meter at the distance of 0.25. So 2 into 0.25, it is 0.5 kilonewton without considering this point load. Then SF at C with point load. SF at C with the point load means adding the 0.5 and 3. So 3.5 kilonewton. So this is the shear force acting at a point C with and without point load. Then SF at D. So SF at D means here considering all the loads. So up to point C, the 3.5 kilonewton load is shear force is acting. So SF at D is equal to 3.5 plus remaining load. Remaining there is an UDL load at a distance of 1 meter. So 2 into 1. So the value of load is 5.5 kilonewton. So this is the load SF shear force acting at the point D. Then between A to D there is no load is acting. So same the shear force of 5.5 load is continued. SF between D to A there is no load is acting. So same load is remain the same load is remain in the between D to A. Again SF at A is equal to 5.5 kilo Newton. So these are the shear force acting on the various points in the various points of this cantilever beam. So SF at B, then SF at C, here we consider with the point load and without point load. Then SF at D, SF at D, here UDL load is acting, as well as this point load is also acting. We are summarize all the load here. Then between D to A there is no load is acting. So the load of SF at D is remain same between A and D. At SF at A also same load 5.5 kilonewton. These are the shear force calculation. Hope you are understood. So next we are going to solve the bending moment. We are going to solve the bending moment. So bending moment, here there are 4 points B, C, D and A. So BM at B, there is load is acting, UDL load is acting, but here there is no distance. Here there is no distance, distance is 0 at this starting point. So the BM at B, the bending moment is 0 kilonewton meter. Here the sign convention for cantilever beam, here the beam is going to bend like this. Beam is going to bend like this. So consider it is a negative bending moment. For a cantilever beam, the bending moment is always negative. So BM, next one, bending BM at bending moment. Bending moment at C. Bending moment at C. Here we only consider load acting the right hand side of the particular point. We don't consider the point load acting on that particular point, because beam is bending like that. Beam is bending like that. So we only consider the load acting right side of the particular point. So don't consider the point load acting at that particular point. So bending moment at C is equal to minus 2 into 0.25 into 0.25 by 2. So bending moment formula for UDL is W into L into L by 2. This is the formula for bending moment for a UDL load. So W into L by 2. Here only consider this UDL load, don't consider this point load. So the load is UDL 2 kilonewton per meter square into distance is 0.25 into 0.25 by 2. So here answer is 0.0625 kilonewton meter. Then bending moment at D. Bending moment at D. So bending moment at D, we are going to calculate the bending moment at C. Here first load is 2 kilonewton. So 2 into the total distance is 1.25. 2 into, so adding minus 2 into 1.25 into 1.252 plus again minus, here point load is also acting. So point, the distance of point load from the point D is 3. So 3 into 1. 3 into 1. The here answer is minus 0.0645 kilonewton meter, minus 0.0645 kilonewton meter. Then bending moment at point A. So bending moment at point A, in point A there is a gap between A to D. There is a gap between A to D. So between A to D there is no load is acting. So but we consider this distance while we are writing the formula for UDL load. So here also there are two load is acting. for a point A bending moment, here also two load is acting, UDL as well as point load. For a point load, the distance is 1 plus 0.25, it is 1.25. For UDL, here I am writing the equation 2 into 1.25 into 1.25 by 2, then adding this remaining distance 0.25, because between point A, so adding this distance to here 0.25 plus, again we can add this add the moment of this point load 3 into the distance is 1 plus 0.25, that is 1.25. Here value is minus 5.945 kilonewton meter. So these are the shear force and bending moment values for this particular beam. So now we are going to draw the shear force and bending moment diagram for this problem. So kindly make a note of it, the formulas and equations, how we are calculating this bending moments. So kindly make a note of it. So now we are going to draw the shear force and bending moment diagram. So first I just use this so draw. So for a bending for a cantilever beam, shear force always positive, bending moment always negative. Here the bending shear force is 0, then here the bending moment is just rising, again the point load is acting 0.3, 0.5, here 0.35 kilonewton, this is 0.5 kilonewton, again the load is rising, this is 5.5 kilonewton. So between A to D there is no load is acting, same this load is remaining 5.5 kilonewton. So this is the shear force diagram for this cantilever beam. Mention here positive sign. Kindly put like this for a better presentation. Have to draw these lines. SFD. Then we are going to draw the bending moment. So bending moment for a cantilever beam is always negative. So here the value is minus 0.0625 kilonewton meter, then here minus 0.0645 kilonewton meter, then here minus 5.94 kilonewton meter. So here you put the negative. So you consider this is the baseline. So baseline, above the baseline you consider the positive, below the baseline you consider the negative. So this is the BMD, bending moment diagram, and also you have to draw these lines for presentation. So also you have to mention the points A, D, C, then B. Here also you have to mention the points A, D, then C, B. So this is the shear force and bending moment diagram for this particular problem. 1 minute, right? So now I am going to show you the solution for your better understanding. Again I am showing the solution. So shear force There are point B, point C, point D and point A. Then bending moment for B is 0, bending moment for at C, then bending moment at D, bending moment at A. Then shear force and bending moment diagram. So shear force for a cantilever beam is always positive, bending moment for a cantilever beam is always negative. This is the curve, this is the parabolic curve and this is the line, because here the cantilever beam, here the UDL load is acting. So this is a curve, this is the curve, parabolic curve, and this is point D to A, this is the line, inclined line. Okay, this is the inclined line. So again I would like to say, for a cantilever beam you consider beam section as the right hand side for a shear force. So shear force right hand side, upward force is negative, then right hand side downward force is positive. That's why all the shear force values are positive. Then for a bending moment have to consider this is the negative. So beam is bending like that. Beam is bending like that. So the bending moment of the beam is considered as a negative. That's why all the values of bending moment is below the baselines. So hope you understand. Thank you.